Hello, this is Lisa Seidman, and this is the fourth in a series of videos dealing with common calculations in the biotechnology workplace. In this video, I'm going to pick up more or less where I left off in the last video and talk about situations where the concentration of a solute, is expressed in terms of a percent. So that's the topic for this video. And this was a slide that I showed in the last video, so just to remind you, I was talking about REPA buffer actually, which is used for lysis. So lysis means to break open cells. Lysis buffer, this REPA buffer, has 5 components: sodium chloride, tris, NP40, sodium deoxycholate, and SDS. The last 3 are all detergents that are used to break down the membrane of the cells. If we look at the way that the solute concentrations are expressed, these two, the millimolar, tris, and NaCl, we'll get to in the next video. But here, we're going to talk about this. We have something, NP40, which is expressed in terms of a percent, 1%, and then it's got this little symbol, W/V. We have 1% sodium deoxycholate and 0.1% W/V of SCS. So those 3 are the topic for this particular video. But before we can really talk about solutions and percents, we need to remember what percents are. Percents are ratios. And the little symbol here, this percent symbol, symbolizes this. We have a numerator, a line, and a denominator. So a percent is a ratio. So for example, since percent, and percent, by the way, is a ratio that means of every 100, so 1% means 1 of every 100, or 1 over 100, or 1 out of every 100. 10% means 10 out of every 100, or of every 100. 0.3 means 0.3 of or out of every 100. That's the definition of a percent. That's what percents mean. All right, so to make this a little bit more concrete, suppose we give an example. Here's an example. You have 500 biotechnology companies. They are surveyed to determine if they hire summer interns. Of those surveyed, 450 reported that they do. What percent hire summer interns? Okay, 450 out of 500 hire summer interns. Well, that doesn't look like a percent. Let's remember that a percent means of every 100. So this we can solve using a basic proportion. If you have 450 out of 500, how many are there out of 100? So we can, again, cross multiply and divide. So we have 450 times 100 equals question mark times 500. And if we solve for question mark, we will get, if you do the arithmetic, you will get that the answer is 90. Well, what does that mean? Okay, 90 is the answer. Well, that means 90 out of every 100 companies hire summer interns. And that's the same thing as saying 90% of them do. Okay, so that's a sort of word problem, kind of percent problem, something like you may have seen before. Okay, now let's talk about solutions. When we talk about solutions, what a percent solution means is the amount of solute per 100 units of solution. The most common way that this would be used in biology would be where we have grams of solute, so amount would be grams, 100 units would be per 100, and the units here would be mils. So when we're talking about biological systems, we're going to usually be talking about grams per 100 mils if we're using this percent nomenclature. And that's where this W/V comes from. It means weight, that would be the grams, per volume. That's the 100 mils. So W/V means we have grams in the numerator, 100 mils in the denominator. So for example, if I say that I have a solution of 2% sodium chloride, that means that I have 2 grams of sodium chloride in 100 mils of total volume. That's the definition of what it means when we say a percent solution W/V. So let's suppose you want to make 100 mils of 0.1% SDS, as one would do. This is part of the REPA buffer recipe. Well, that's simply 0.1 grams of SDS. So you'd weigh that out on a balance, you dissolve it in water, and you would bring it to a volume of 100 mils. BTV, bring to volume. Okay, that seems pretty straightforward. But let's suppose that you want to make 300 mils of 0.1% SDS. So now what would you do? Well, now we still have the same question. How much SDS should you weigh out? Well, we can solve this, again, using our same logic. We know that a 0.1% solution is 0.01 grams of SDS in 100 mils of volume. So if I want 300 mils, put the 300 mils here, how much should I weigh out? Well, again, we can solve this as a pretty straightforward proportion problem. And if I solve that, question mark equals 0.3 grams. So that's how much I would weigh out and then bring to a volume of 300 mils. Now in another class you might have seen this written as sort of a shorthand. So it would be perfectly fine to solve this by saying 300 mils times 0.1 grams per 100 mils. And you're going to get the same answer, which would be 0.3 grams. So that's how much you would weigh out. Okay, let's go on to look at some other kinds of problems. Another way to express concentration as a percent is a V/V. And that's for chemicals that come as liquids. So if a chemical comes as a liquid, we have a volume in the numerator and a volume in the denominator. So that would be the volume of solute would be in the numerator per 100 mils of solution. That's what a V/V means. So let's look at an example of that. Suppose that you want to make 500 mils of 10% V/V, volume over volume ethanol and water. Ethanol is alcohol, it comes as a liquid. So we know that 10% V/V would be 10 mils of ethanol per 100 mils of water. But we want 500 mils. So how much of it do we have to measure out? How much of the ethanol do we have to measure out? So we can again solve this for a question mark, and we come up with question mark equals 50 mils. So that's how much ethanol we would measure out to get our solution. And then again we would bring it to a volume of 500 mils. And I want to point out here that this is a situation where it's important to actually bring it to volume. So you might think, well, if I need 50 mils of ethanol, then I need 450 mils of water. So I'll just measure out 450 mils of water and 50 mils of ethanol. And it turns out that when those two combine, ethanol and water, if you took 450 of water and 50 mils of ethanol, you probably would not get exactly 500 because of the way they interact with each other. So it's important to bring it to a volume using a graduated cylinder or maybe a volumetric flask. Okay, so these are the most common types of percent solutions that you're going to see. But the third way is W/W. So that would be grams of solute per 100 grams of total solution. This particular nomenclature, grams over grams, is very uncommon in biology applications because we're almost always talking about things in water, and we tend not to weigh water. We measure it out with a pipette or something like that. However, you might see this in more chemistry applications, and you might almost certainly will have seen this in a chemistry class, because this is the way that chemists like to think about it. So I'm not going to go any deeper into that, simply because it's very uncommon in our biology applications. So now, here are 4 problems for you to try to solve yourself. So what I would suggest that you do is to pause the video, and then go ahead and take a look at these problems, and then in a few seconds I will start the video again, and we can take a look at some answers. Okay, let's have a look. So the first one is a laboratory solution contains 5 mils of propanol per 100 mils of solution. This is pretty simple because what we have is 5 mils of propanol per 100 mils. You'll notice that this is a V over V solution, volume over volume, and by definition 5 mils out of 100 mils is simply 5%. So by definition, this first one is a 5% solution of propanol. All right, that was the first one, the first problem. Okay, how would you prepare 600 mils of a 15% W/V solution of sodium chloride? Well, again, we can use the same logic we've been using before. 15% W/V means 15 grams per 100 mils. But we don't want 100 mils, we want 600 mils. So you can again set it up like this, solve for question mark, and you will get, if you solve for question mark, the answer would be 90 grams. And so you would weigh that out, 90 grams of the sodium chloride, and then you would bring it to your volume of 600 mils. Okay, that's the second one. Suppose you have 50 grams of solute in 500 mils. Express that as a percent solution. Well, all right. We know that we have 50 grams per 500 mils. And we know, by the way, that this is going to be a W/V solution. So we can say, in order to make it a percent, we have to make it on the basis of 100 mils. So we can again set up our proportion problem. And we have that question mark equals 10. And that means that there are 10 parts of the solute in 100 mils, which means that this is a 10% solution. And I'll just make a note here that if you don't see a W/V or V/V or whatever, and it's a biological application, you can usually assume it's W over V, because this is the way that is by far the most common in biology, biotechnology settings. Okay, let's have a look at this last one. Now, we've been talking about, we've always had easy units because we had grams and mils before, but here it says 100 milligrams of solute in 1 liter solution. So how do we do this one? Well, pretty easily. First of all, we can convert our units to be the correct units. So 100 milligrams is the same thing as 100 divided by 1,000 as 0.1 grams. And 1 liter equals 1,000 mils. So we have here 0.1 grams in 1,000 mils. Well, what would that be on the basis of 100 mils? So again, we can solve for question mark, and we get that question mark equals 0.01 grams. So if we have 0.01 grams out of 100 mils, that means that we have a 0.01% solution. Because remember, we're always remembering, what does a percent solution really mean? So we have here 0.01 grams out of 100 mils. That makes it a 0.01% solution. All right, so that's the problems for this video. And I just want to note that in the next video, we are going to look at the sodium chloride and the tris. Now here we have millimolar, so we're going to start out in the next video. We're going to talk about this big M, and then we'll get to this where you see a big M and a little m. And that is the subject for the next video. See you there.